Hello and welcome to horticulture class. My name is Mrs. Tessarose Mahmoudi and this lecture is all about climate and plant growth. Last time we talked about what plants need to grow. We talked about the water requirements, the temperature requirements, the light requirements, nutrients, and air requirements that plants have in order to grow. This time we're going to talk more about how these different elements vary in different climatic areas. You may recall a similar graph from the History of Horticulture lecture. I made a similar graph for plant growth. At the bottom we have plants' basic needs. For example, most plants require water and warmth to germinate. If that seedling is going to continue to grow, it's going to need a favorable environmental condition. It's going to need the right temperature, amount of sunlight, and even dark time, along with security, meaning that it's not going to be disturbed, and nutrients and carbon dioxide. For that plant to continue to grow and be productive, it's going to need to be adapted to the environment that it is growing in, meaning that it's going to be a favorable location. It's going to have to start partnerships with microbial symbionts in the soil, along with being supported by the ecology in general, meaning that it's not going to be taken over by certain animal or killed by another plant. It's going to have to be adapted to the weather patterns and the general climate there. Moving up further, as that plant is growing, it also needs to stay healthy. In order for the plant to stay healthy, it needs to have immunity to the diseases that are in that area. So just like some people get the flu shot and then they're immune to the flu, or some people will get the cold one season and others will not, some plants have immunity to certain diseases, just like some people are immune to certain diseases because either they've already had it or their body already has antibodies for it, they don't get sick. So plants also have these health needs. Immunity is the ability for that plant immune system to defend against that disease. And IPM is something that we as horticulturists and agriculturists can do to make sure that our plants stay healthy. IPM stands for Integrated Pest Management, and that's something we'll talk more about later on. If all these needs are met, that plant can then make future impact, meaning that it will be able to produce seeds or other way of propagating, and that plant will grow into the future as the next generation and be able to provide food and ecological services. These different factors that plants need that we covered vary in different geological locations around the world. So as an example, I'd like to go through 3 pictures that I took during my travels. First, I'd like to show you a picture that I took in Acadia National Park in Maine, United States. The next picture is from Rio de Janeiro, Brazil. And the third picture is taken in Arizona. So as we look at these 3 pictures, again, this is from Acadia National Park in Maine. This is near Rio de Janeiro, Brazil, and this picture is taken in Sedona, Arizona. Just by looking at these photos, we can start to feel what the climate feels like in that area. So if we see in this picture, we might get a feeling that it was cold. When I took this picture, it was pretty cold. If we look at this picture, we can kind of imagine that it's very humid and very warm. And if we look at this picture, we got to get the sense that it's very dry, very hot. So just by these pictures, we can tell that these places have different or unique climates. The temperature is different, the amount it rains is different. So in all of these pictures, we know that these climates do get rain, but the consistency or amount of rainfall per year is different. The humidity is different, the amount of sunlight throughout the year is different, and how windy it is throughout the year is also different. So we're going to further understand the definition of climate. So climate is the average atmospheric condition over a longer period of time, while the weather is the current and temporary atmospheric condition. Old men and women love to sit around and talk about the weather. They're talking about how sunny it is, might be complaining about the lack of rain or too much rain. We're talking here about weather. If someone's going to talk about climate, they would be talking about their vacation, such as where they're going. They might be visiting a different climate, which might have a different temperature in that certain time of the year. Maybe they want to escape the winter. Maybe someone wants to escape the heat. They would be traveling to a different climate. If you're sitting around complaining about the weather too often, you might consider moving to a different climate, because different regions have an average temperature and humidity and precipitation that you might just not prefer. A different climate might offer a different average for you. There's different climate zones. The most basic levels would be polar, very cold, temperate, and then tropical. Tropical meaning very close to the equator. There's other classifications that we're not going to go into right now, but that you should know about, thinking of like rainforest, desert, these tundra. These are things that you've heard of. So different plants are adapted to these different climatic regions, and knowing which region you're in and your specific climate is helpful for choosing the right plant for you. So what elements make up climate? These are really the ones that we were talking about when we were looking at the three photos. Temperature, which is necessary for proper life processes. Precipitation, plants need water. Humidity, which alters the amount of water that plants use, or the transpiration, which is water movement through plants. Light is also different in different climates, which is important because different plants require a different amount of light for photosynthesis. And the last one is wind, which is important for airflow and can also affect temperature. So as far as temperature, this one should be relatively straightforward. Different plants require different temperature. We'll talk later on about how certain plants actually require a cold period to do certain biological processes. For the most part, most plant processes happen at their highest rates in warmer weather, but the adaptivity of plants to different temperatures does vary. Precipitation varies in different regions. I want to take the time to go over a few different precipitation terms that you might not be familiar with. Of course, we know dew, mist, fog, rain, hail, and snow. We're going to get into more about what those actually mean, although I'm sure you're quite familiar already. The water cycle really affects plants, and plants are a part of the water cycle. So these terms might be familiar to you, but we'll go over them nevertheless. So when there's standing water, water evaporates, and then water can then get into the atmosphere through transpiration, which is water loss from plant leaves. So water is uptaken through the roots of a plant, and that plant then transports that water through the plant, which is very important for different biological processes happening in the plant. And then the water is then transpired. That water then is in the atmosphere, can condense, and then we have precipitation. So basic overview of the hydraulic cycle or the water cycle. Humidity also affects plant growth because it affects how fast transpiration in plants happens. If transpiration is too high and there's not enough water in the ground, the plants can run into huge issues such as water stress and even death. If it's really humid, plants do not use as much water because the water isn't evaporating as much. The inverse of that, if it's very dry out, plants are going to lose water at a higher rate. Think of it as water or sweat on your skin. If it's very humid out, that water or sweat is going to just sit on your skin. But if it is very dry out, that sweat or water is going to evaporate very fast. That's why some people really don't like humid weather. Talk about the humidity, that percent on the news. They are giving us the relative humidity, or the amount of water vapor in the air expresses a percentage of the amount of water vapor that could be held in the air. So if the relative humidity is 100, we know that it's going to start raining soon. Often, the higher humidity that is in an environment, the better plants will grow because they're losing less water. That being said, too much humidity isn't good either because fungus also prefers high humidity, which can cause a disease epidemic. Low humidity will not seriously hinder plants, but if they don't have enough water, they're losing a lot of water and they will have drought stress quickly. A lot of times this happens in cold climates where you have indoor plants. It's very dry inside your home. You forget to water the plant, and that can cause death. Some more terms for humidity. So the dew point is when the temperature where relative humidity equals 100%. Condensation occurs, and that's the conversion of water vapor to liquid or ice, and that occurs when the temperature drops below the current dew point. Precipitation is the loss of this atmospheric water to the earth through force of gravity. There's different types of condensation. Water can condense on solid surfaces, and we call that dew. Water can condense into small droplets near the earth, and that's called fog. And water can condense in small droplets high in the atmosphere, and we call those clouds. When condensation occurs above freezing, that means when the air is warmer, we get rain. We can either get a drizzle, which is small droplets of rain, or we can get larger droplets of water, which we call rain. Basically, if it's drizzling outside and you go outside, you won't get too wet. If it's raining, you will get more wet in the shorter period of time. Condensation, if it occurs below freezing, that's how we get snow. So when the atmosphere is very cold and the water condenses, then the crystals are able to form into these beautiful snowflakes. Condensation, when it occurs above freezing, say it occurs, the condensation occurs here, and then as the water droplet is falling to earth, if it passes through a layer of coldness in the atmosphere, that water can then freeze. So that rain droplet became frozen, and now we call it sleet, which is frozen rain. If that droplet goes a little bit lower down in the atmosphere and falls through another cold area, if it goes through another cold area and then gets frozen again, basically the droplet will get larger. So we have liquid, it gets frozen, then maybe the air. If condensation occurs above freezing, but then it goes through a cold layer, we can have sleet form. So we have water condensing, so we have rain, and then as it's falling to earth, it goes through a cold layer, becomes frozen. Then it is frozen rain, which we call sleet. If that frozen droplet of rain then has more water condense on it, and then falls through another cold area, it will get frozen again. What happens is this droplet keeps getting larger, which is how we form hail. The larger the hail, the more layers of coldness and condensation that's occurred on that specific droplet, making it larger. So the droplet is in the atmosphere, it circles back through wind, higher point of the atmosphere, it gets more water, it goes through a cold area, gets frozen, goes through a little bit warmer layer, has condensation occur, goes through another cold area, gets frozen. You can get either pea or golf ball-sized hail, which is not good for our cars or our plants. So that's a general overview of how hail is formed. Next, we're going to talk about light. Light duration, intensity, and quality affects plant growth, and the amount of light that different areas of the world receive is highly dependent on the distance from the equator and the season that we're in at a certain time. At the equator, day and night are equal all year long. North or south of the equator, days become longer in the summer and shorter in the winter. Plants vary in the amount of light that they need. So these are two common garden plants. This one is zinnia and this one's hosta. If you buy these plants, it's very important to know where to plant them. Zinnias love to be in full sun, whereas hostas need to be planted in the shade or else they'll not do well. Full shade, to help you out, different plants are labeled with full shade, partial shade, or full sun. This is describing to you where you should plant this plant. If the plant tag, or if you Google this plant and it says full shade, that means you should plant the plant in an area that rarely gets direct sunlight throughout the day. If a plant is labeled partial shade, it means that you should plant that plant in areas which receive direct sunlight for about 1/3 or 1/2 of the day. Usually this means planting the plants to help you out to know where you should plant your specific plant that you bought. Many garden centers label. To help you out, many plants are labeled with either full shade, partial shade, or full sun. This helps you know where you should plant your plant. If a plant that you bought is labeled with full shade, you should plant that in an area that rarely receives direct sunlight. If your plant that you purchased If the plant is labeled with partial shade, you should plant that where the plant rarely receives direct sunlight. This could be under a tree with very fine foliage, meaning that there's going to be some light that plant can get throughout the day. If a plant is labeled full sun, this means you should plant it where the plant is going to get direct sunlight almost all day long. This is usually on the south side of a home, but you can find it on other areas, depending on where you live. If you don't know what type of plant you have, you can also Google the plant and see what its light requirement. You should plant partial shade plants in areas which receive sunlight for about 1/3 to 1/2 of the day. Or you can plant them under a tree that has light foliage, meaning that the light will get through. You should plant partial shade plants in an area that will get filtered sunlight, such as underneath a tree with light foliage, or in an area that receives sunlight for only about 1/2 or 1/3 of the day. If you have a full sun plant, you need to plant that in an area that will get lots of sun throughout the day, usually on the south side of your home, but just take note of where the sun is shining most of the day in your yard. Let's go over a few examples in case you're confused. So, number 1, what type of plant do you think that you should grow here? A, full shade, B, partial shade, or full sun? If you said partial shade, you're correct. Number 2, we're planting this plant underneath this large bush with thick foliage. It's shaded most of the day. If you said full shade, you're correct. What about this third one? In the open, where there is no shade at any point of the day. If you said full sun, you're correct. Wind also affects plant growth. For example, ocean wind can limit the amount of plants that can grow near the shoreline because of salt spray, which browns plant leaves. Sometimes there's very intense winds near the ocean, and it has this salt in it, and it can damage plants. Furthermore, other areas will have severe wind, and that can be damaging of plants. Certain plants are adapted to grow where it's really windy. Hot deserts, if they have increased winds, this will increase the rate of moisture loss through plant leaves, so increase the rate of transpiration, which is water loss of plants from plants. And this can make the plant have drought conditions, which means loss of water. When in a cold area, when the wind blows, such as in northern areas, it can damage plants, such as damage evergreen plants. More water will be evaporating from the plant leaves, and that will reduce moisture and can cause what's called freeze drying. So in review, we talked about how temperature, precipitation, humidity, light, and wind are elements of climate. There are some other factors that modify climate, and we're going to talk about them now, such as distance from the equator, topography, such as elevation and terrain, and the nearby presence of large bodies of water. Climate modification by humans will also be discussed. So let's talk about distance from the equator. In this graphic, you can see the Earth and different lines on it. What are these lines? So the center line is the equator. Then we have the Tropic of Cancer, Arctic Circle, and North Pole. In the summer hemisphere, we have the Tropic of Capricorn, Antarctic Circle, and South Pole. Between these different lines of latitude, we have different zones of climate. Near the equator, we have the tropical zones. Further away from the equator, we have the temperate zones, both in the northern hemisphere and the southern hemisphere. We also have the polar zones in the southern hemisphere and northern hemisphere. So the distance from the equator affects how much sunlight the Earth gets in that specific location, which affects the climate. And to further talk about how the sun influences the temperature at any given point of time and place, we need to talk about seasons. Do you know why seasons change? If you said the Earth's rotation, you're correct. So let's talk about terrain, which is the shape of the Earth. The shape of the Earth has a big effect on the climates at different locations. For example, elevation. As you get higher in a mountain, if you're mountain climbing, it's really important to pack layers, because as you're climbing up, it's going to get colder. So you're going to want to bring an extra layer or two, depending on the mountain. Every rise of 300 feet, or around 90 meters, you will have a 1 degree temperature drop. So this is really important not only for mountain climbers, but also for plants. Different plants are adapted for different elevations because of the temperature. This is because the particles, as you go higher into the mountain, This is because as you get higher into the mountain, the particles are going to be more spread out. This means that they're going to have less energy and less heat. So as the particles are bumping into each other less energy, and therefore it's going to get colder. The next thing I'd like to talk about is terrain, is a rain shadow. This is a really interesting phenomenon. An excellent example is in California, near the Pacific Ocean. So let's talk about what this phenomenon is called a rain shadow. So off of the ocean, we have lots of clouds forming, which is pretty expected because we have a huge body of water. As these clouds move inland, they move to the land. And as these clouds are moving, going on their merry way, they hit the mountain, which causes them to go up into the atmosphere. So the clouds are forced to move upward. With this upward movement, they go higher. Higher meaning it's colder. Colder air can hold less water, so this causes precipitation. That's why you often hope that there's a slight temperature change if it's really humid out so that it will rain. So if it's really hot and humid out and the temperature goes down a little bit, that means the atmosphere can hold less water and it's going to rain. So same thing here, the clouds move upward, it gets colder, we have precipitation. The result of that is that this side of the mountain gets lots of precipitation, but because these clouds rarely make it all the way over here, or very few of them do, this side is very dry, and we get even desert-like conditions. This is called a rain shadow. This is really important to consider for horticulture because we can grow crops on this side of the mountain, but not this side of the mountain we can grow crops, but this side we couldn't. This is why land prices vary a lot in different regions. You have to be smart about how much rain you'll get in a certain region. Next thing I want to talk about is large bodies of water. Water holds heat better than air, or longer than air. So water can hold temperature. It's also harder to change the temperature of water. So if water is really warm and then it's cold outside, the air is going to change temperature right away, but the water is going to stay warm and then slowly lose its heat to that environment. That's why in the fall time we often see this steam coming off water, because the air is much colder than the water, because water holds its heat better. Enormous volumes of water absorb heat in the summer, and then they can make the adjacent or nearby land much cooler. And then that heat that the water has gained all summer also is given off in the winter, which raises the temperature of the land. Warmer winter temperatures along the Great Lakes make this region a large commercial growing area for fruits such as grapes, cherries, and peaches. So we can see these large bodies of water are affecting the amount of plants and the type of plants that we can grow in that area. As I said before, California is an excellent example of a rain shadow and this large body of water effects. So not only does this area near the coast get more rain, it also is warmer because of the Pacific Ocean right here. Let's talk about the modifications that humans have on climate. We could talk much further about this, but we're just going to go over it briefly. People can modify climate intentionally or unintentionally. Smog, which comes from pollution, affects plant growth by temperature modification. It acts as an insulation layer, preventing heat to escape, and this causes a warming. Particulates settle onto leaves also and can decrease the light that plant gets. This is a picture of LA, one of the most polluted cities with the most smog, and smog affects plant growth there and in other areas through injuring the foliage by toxic gas entering the leaf, causing them to brown and sometimes even die. Some plants are very sensitive to pollutants and can't even grow in smog areas. Example of an intolerant plant is pine trees. So in summary, climate is different than weather. Weather is what we talk about in a coffee shop, whereas climate is something that we talk about when we talk about traveling to a different area. Elements of climate, we went over those, and those affect plant growth. That's why we have plants that are diverse in unique climatic environments. And there's other factors that affect climate, such as topography, large bodies of water, and even human effects. Thank you so much for your time, and next time we will go build on this information to know how do I know which plants to grow in a specific area. We will go over plant heat zones, plant hardiness zones, taking advantage of microclimates, and plant adaptive strategies. Thank you so much for your time.